Good day everyone. My name is Christian Morales and I'm a member of Group 8. And our topic for today is all about carbon fiber reinforced plastic or CFRP. And as I mentioned, I am a member of Group 8 and in our group there are 5 members. There's me, there is Donita Marie O. Caniban, Earl Lawrence S. Resonable, Kurt Andre de Jesus, and lastly, Hiran Caneligo. And our flow of our reporting is introduction or background of the material would be tackled by Kurt Andre de Jesus, followed by Donita Marie O. Caniban, then Hiran Caneligo. After that would be Earl Lawrence Razonable, and the rest would be me, and a conclusion which be tackled by me, Christian Morales. And I hope that you would enjoy and listen to our reporting, and that's all. And I leave now, and I will give you to the next reporter, which is Kurt Andre de Jesus. See ya.
Good day everyone, I am Kurt Andre de Jesus and today we will know about carbon fiber reinforced plastic. Let me tell you a brief history of carbon fiber. Carbon fiber has been around for more than 150 years. It has only been through manufacturing process improvement in the last half-century, so that its excellent strength to weight and stiffness to weight ratio have been achieved. This modern advice coupled with this decrease in manufacturing costs over the last couple of decades are what have made carbon fiber become such a popular material for design, engineering to use in some of today's greatest technological advance. Sir Joseph Wilson Swan first created carbon fiber in 1860 to use in an early incandescent light bulb. In 1879, Thomas Edison used cellulose-based carbon fiber filament in some of the first light bulbs to be heated by electricity. Their high heat tolerance made them ideal electrical conductor. These filaments were made of cotton or bamboo as opposed today petroleum-based raw material and then baked at high temperature to cause carbonization to take place. This baking method called pyrolysis is still used today. Pyrolysis is the process of thermal decomposing organic material by heating it at high temperature in an insert atmosphere. When tungsten became the light bulb filament of choice in early 90s, carbon fiber was considered obsolete for the next 50 years or so. Did you know all about carbon fiber? Carbon fiber are industrial produced fiber which are refined in such a way that they consist almost exclusively of carbon. They are microscopically small and about 8 times thinner than human hair. There are many different carbon fiber types, but let's discuss this one, a carbon fiber reinforced plastic. What comes into your mind when you hear carbon fiber reinforced plastic? Carbon fiber reinforced plastic is a real high-tech material with its properties that dwarf those of steel and aluminum. It is constantly opening up new areas of application and has already become indispensable in many areas, which take you on a voyage of discovery into the world. Carbon fiber and see how microscopically thin fiber are ultimately turned into carbon fiber reinforced plastic. That's all. Thank you.
A pleasant day to each and everyone. I am Donita Marie Caniban and I'm going to tackle about structure of the materials. So first, what is CFRP? CFRP is the abbreviation for carbon fiber reinforced plastic. CFRP is a material consisting of several constituents, a base or carrier substance, also called matrix, and a second reinforcing component, the carbon fiber, which is embedded in the matrix. Usually, a synthetic resin is chosen as matrix material. The cured composite has different mechanical properties depending on the type of carbon fiber used, the matrix, and the manufacturing process. Carbon fiber reinforced plastic is a real high-tech material, with its properties that dwarf those of steel and aluminum. It is constantly opening up new areas of application and has already become indispensable in many areas. The diagram illustrates the different ways of manufacturing a CFRP component. First and second is a carbon fiber and a carbon fiber fabric. And the third is resin. The fiber is cut and laid into the mold, then resin is applied by a brush or ruler. Next is winding. Fifth is laminating. Next is curing in autoclaves. Cured into the mold under the heat and pressure in an autoclave. Next is pressing and curing. And the last is machining. Machining is the process that creates the desired shape by removing unwanted material from a large piece of material.
So, what are the physical properties of carbon fiber reinforced plastic? So, carbon fiber reinforced plastic is more than 4 times as stiff as glass reinforced plastic, over 20 times stiffer than pine, and 2 times stiffer than aluminum. Although carbon fiber doesn't decay on its own, epoxy, which is a thermoset plastics made by the reaction of two or more industrial chemical compounds, and it is often used to fix broken objects to create a sealant. It needs to be covered from sunshine because it is photosensitive. It is also up to 5 times lighter than steel, and it is approximately 60% as heavy as aluminum, which makes it lightweight and resistant in most significant advantage. While the chemical properties of carbon fiber reinforced plastic is that carbon fibers typically have good thermal and electrical conductivity, low densities, high thermal and chemical stabilities in the absence of oxidizing agents. And it is also excellent in creep resistance, and about 90% of the carbon fibers that are produced are made from polyacrylonitrile, which is usually used to make other polymers like carbon fiber. Fibers of polyacrylonitrile have been used in hot gas filtration systems, outer awnings, sails for yachts, and even fiber reinforced concrete. Most of the polyacrylonitrile is produced as acrylic and mud acrylic fiber, which is a common substitute for wool in clothing and home furnishing. While the remaining 10% are made from rayon or petroleum pitch, which is a residue from heat treatment and distillation of petroleum fractions. It is a solid at room temperature which consists of a complex mixture of numerous predominantly aromatic and alkyl substitute aromatic hydrocarbons. And it exhibits a broad softening range instead of defined melting temperature. All of these materials are organic polymers characterized by long strings of molecules which are bound together by carbon atoms. High fatigue strength, X-ray transparency, and minimal thermal expansion are other chemical characteristics of carbon fiber reinforced plastic, and an individual component's precise qualities can be targetedly influenced, managed, and maximized.
Carbon fiber reinforced plastics or CFRP application. Carbon fiber reinforced plastics or CFRP are now being used in primary structures of airplanes, ships, and other vehicles for and for applications that demand sustained high reliability during long-term operations. Today, the most common applications for CFRP are in aerospace, automotive, and wind energy, in medical technology, robotics, automation technology, measurement technology, and optics, as well as in mechanical engineering and in the sports and leisure sector. CFRP can be used in many different ways. Carbon fiber reinforced plastic advantages. It is lightweight, which means fewer resources workers are needed to deliver and complete the project. So it cost effective option. It has high fatigue resistance and the flexible carbon fiber crack far less frequently than other traditional alternatives like concrete and steel, especially when they are subject to cycle loading. Carbon fiber reinforced plastic has a higher tensile strength than materials like aluminum and steel. This means that carbon fiber handles more pressure than its traditional alternatives. It survived most severe environmental conditions like humidity, rainfall and radiations, and chemical exposure, and more. It doesn't corrode or deteriorate, so any structural elements coated in carbon fiber will continue to work efficiently. Carbon fiber reinforced plastic disadvantages. Carbon fiber reinforced plastic products are expensive compared to the other structural building materials used for the same jobs. Though, while products like aluminum and steel are cheaper initially, they require more manpower due to the weight. We always recommend booking a cost analysis before making a decision. That way you can notice the price difference and whether it is worth it for you. It conducts heat and electricity, so it may not be the best choice for your project if your building or structure works with either of these elements. We always recommend booking feasibility analysis to see whether carbon fiber reinforced plastic is the right option or whether there's a suitable alternative. Despite the excellent performances of CFRP composites, why carbon fibers not widely used in product production? At present, the production cost of CFRP composites materials is too high according to the current market conditions. The size of fiber bundle is different and the price of the fiber is also judged.
To sum up all the topics about carbon fiber reinforced plastic or CFRP, CFRP is or one of the key parts or important materials in our lifetime, especially creating or developing technologies or using it in a building, our house, or any infrastructure. We know that CFRP can compete with other materials and also beat some materials in terms of standards, quality, and durability. CFRP can also handle heavy load where some of the materials will reach its capacity level. And CFRP is also a light material and very durable, which is also important in making aircrafts, boats, parts, and other things. CFRP is good, but all good is not what you may think it is. There are so many disadvantages of owning or buying a CFRP. Like, for example, it is very expensive than aluminum or steel. We know that CFRP is durable and flexible than steel and aluminum, but it is expensive in creating a device. The client wanted their technology to be durable and long lasting. So, buying a CFRP is not in their budget. So, the client will go to another material or any alternative material or cheaper than CFRP such as steel and aluminum. And this may apply as into building as well, like building materials. And safe RP is also a very is also very bad. Right? It can conduct heat and electricity, which is dangerous if you are working with electricity and fire. So it's so dangerous that it may lead into some serious injury. To end my conclusion, I may leave some short tips or warnings with working with CFRP. Um, with working with CFRP, just with the fire, just wear gloves or any proper equipment that can protect you with your skin or any parts of your body, and have a first aid kit in your workplace or in your kitchen. And and working with CFRP, uh, you must needed proper tools or necessary tools with working with CFRP to avoid any serious injuries or it, um, for for things sure is like death or I don't know. But with working with CFRP, like just just remember the quote, safety first, and that's all. Thank you.